Okay, time to start. Good morning, everyone. My name is Peter. I'm one of the Gradle core developers. And together with Perryn, I'll lead you through this workshop today. Perryn, do you want to introduce yourself? So we have 3 slots today. The first one is going to be 45 minutes. Then there's the lunch break. Then we have another 45 minutes, a small break, and another 90-minute breaks. So 3 hours total. That's what we've got today. And for the first part, of 45 minutes, I'll do the talking, and Perryn will be the background act and help you with any problems, especially during the labs. If you have any questions during the labs, if it's something that's of interest for everyone, just let me know. I'll repeat the question, and we can discuss it. Otherwise, Perryn will always be around. We even have a third Gradleware guy around, which is Gary. So we have lots of staff around to help you with the labs and any other questions you might have. So what are we going to do in this workshop? We have a number of topics. I'll present a topic, and after that we'll do the lab for the topic. And we'll repeat that a couple of times. So we have lots of hands-on labs. If you have questions, we should have time, so ask right away. If I can't answer a question immediately, we'll do it in the break or afterwards, but we do have time to answer questions during the workshop. The labs. Pairing on the labs is encouraged. Usually that works really well. The pairs are usually always the ones that complete the labs first. So I encourage you to pair if you want to. You do have the solutions on the stick, but please try not to cheat. But maybe you can have a look at them afterwards. And the first lab is going to be the Gradle installation setup. So just try to get hold of the USB sticks that are wandering around, copy that one file, and all the rest we'll do as part of the first lab. So what are the objectives for this workshop? Of course, we want to start with a Gradle introduction, so we don't assume that you have any Gradle background. We do want to cover some of the most fundamental concepts, but we are trying, even in only 3 hours, to go a little bit beyond just using Gradle. So we'll build, master a little bit, and write our own logic, our own tasks, perhaps even our own plugin, so that you get an idea what it's like to be a build master and not just a build user with Gradle. And at the end of the workshop, we'll look at some of the newer features of Gradle. This is the detailed agenda. So these are the topics we are trying to cover. First of all, some general information about Gradle, then some Groovy and Gradle basics. The Groovy basics will be very short because we just had the Groovy workshop. By the way, who of you did attend the Groovy workshop? Okay, about half the people. Okay, fine. Then we'll come to the first building block of Gradle, which is Gradle tasks. We'll talk about tasks in general. We'll have a lab for that. And then a little bit more interesting of a topic, task inputs and outputs. That's something, if you don't know Gradle, you might not be familiar with that. After that, we will talk about higher level concepts. Next thing is plugins, and in particular the Java plugin. After that, we'll talk about some random features, some newer features that you might not have heard of. And if there's time left, we'll talk about dependency management in the end. Of course, there's a lot to say about dependency management, and depending how much time we have left, we will expand on the topic of dependency management with Gradle. Okay, so let's get started. So what is Gradle? So we say that Gradle is a build tool with a focus on whole project automation. So there's a lot of things to automate in an enterprise build. It's not just building your binaries. Lots of other things like creating your documentation, pushing the documentation to your website. And that's why we call Gradle a whole project automation tool. And we do support multiple languages and by now even multiple platforms. You probably heard that we have quite strong support for C++ already, and we'll continue to expand to other platforms than the JVM. JVM is where we started out, and probably where we are currently strongest. But we try to cover as many platforms as we can because pretty much every enterprise has a heterogeneous environment, many different platforms, maybe front end in .NET and back end in Java. And we think it would be a really good idea if you could use one build tool for all these platforms. Gradle was created in 2008, so it's already in its 6th year. It's implemented in Java and Groovy for the outer layers, but all the core is implemented in Java. So feel free to check it out on GitHub. It's all available on GitHub if you're interested. Maybe even helping out with the implementation. It's all written in Java 1.5, which makes it rather approachable. And it's, of course, open source Apache license too. Now, let me talk a minute about Gradleware. So we are the company behind the Gradle build tool. We employ most of the full-time, or all of the full-time engineers. We do have lots of open source contributions, but the core engineers are employed by Gradleware. We offer consulting support and development services around Gradle. So if you want to introduce Gradle into your organization, or maybe have some large migrations going on from some other build tools, we'd be happy to talk to you. And we have a booth out there, and Ruth would be very happy to talk to you. We also do a lot of trainings. We do virtual online classes, we do public trainings, and we do in-house trainings, where we come to your organization and deliver a training, tailored to your needs. And we also have, we offer more strategic consulting, not just about Gradle, but for example, if you want to build out a continuous delivery process, we can help with that, with the more strategic consulting services. We are based all around the world, but that especially developers are spread around Germany, Australia, Poland, Austria, Canada, US, and probably that doesn't even cover all countries anymore, which makes for very interesting meetups. So the developer meetup, the weekly meetup is, for me, it's 10 p.m. right now. Tuesdays, 10 p.m. And for you, it's like 6 a.m. So we are a really distributed gang. OK, so I already said the source code for Gradle is up on GitHub, so check it out if you're interested. The best way to get support is forums.gradle.org. So all of the core developers and the community are listening there, so that's the best place to get answers. You can also use Stack Overflow, but chances are that you get better answers on forums.gradle.org. And we do also offer a commercial support. So if you're interested in that, please talk to Ruth. And we have commercial support with guaranteed response times. Whereas forums.gradle.org is, of course, a best effort service. What do we have in terms of documentation? Especially if you're new to Gradle, it's good to know where to look. So first of all, we have the user guide. This is the comprehensive manual. By now, it's probably 400 plus pages. It has many samples, in-depth explanations. It comes in various forms. Personally, I prefer the single-page HTML version because it's very easy to search in that. So if you have an idea, if you have a keyword in mind, what you're looking for, then I always do a browser full-page search on that single-page HTML. And if you do that, you'll be able to answer like 75% of all questions asked on forums.gradle.org. So often I don't know the answer, but by now I know which keyword to look for. And I just open single-page HTML, full browser search, and copy and paste the answer, and that makes some of the people really happy. So that's a good way to look for information. If you're more interested about how can you implement your build script, and we'll do that today. So what's the Gradle build script language, then the DSL reference is a good choice. That's kind of similar to Java Doc, but higher level. So it explains the Gradle build language, the scripting language that you can use in a Gradle build script. So the DSL reference is more focused on that. And both of them are, of course, up on Gradle.org. And both of them are also contained in the full Gradle distribution that's on the stick. So that's in that zip file. You have the Gradle all, and the Gradle all contains both the user guide and the DSL reference. Yeah, in terms of downloads, there are basically two downloads: the bin, which is just a binary, and the all, that also contains the source code, all the documentation, and also many samples. So if you want to see fully working self-contained Gradle samples, like how do I get started with a Gradle war build, or a Scala build, or a Groovy build, or a C++ build, then download Gradle all, which you already have by now, and look into the samples folder. And there you have like 100 or 200 self-contained builds that you can just execute right away, and that get you started with various technologies. OK, so current latest Gradle release is 1.12. Was released on April 29th. And and that's the version we are going to use in the workshop. As you heard this morning, 2.0 is coming soon. RC1 is already out, so we'll have 2.0 soon. But in terms of technology, the difference won't be big. So Gradle 2.0 is just like, technically it's more like Gradle 1.13, but as Hans explained, compared to 1.0, we've made a lot of progress, and that's why we decided to bump it to 2.0, but it's really not a big deal to get your builds from using 1.12 to 2.0. Okay, let's start out with Groovy and Gradle basics. So one more question. Who of you is new to Gradle? First time that you're using Gradle today? Lots of people. Great. You're in the right room. That's what the workshop is intended for. Okay, so what is Groovy? If you haven't heard about Groovy before, Groovy is a modern scripting language for the JVM, or a dynamic language, but it's especially good for scripting purposes. One of Groovy's design goals is to be easily picked up by Java developers. So it's very close to Java, both in syntax and semantics, especially in syntax. The Groovy syntax is almost a superset of the Java syntax. So 95% of valid Java syntax is also valid Groovy syntax. So you just rename .java to .groovy, and you've written your first Groovy program. That's how close it is. That's not particularly important for our purpose, but it's perhaps interesting to know that Groovy is still a compiled language. So many people think Groovy is an interpreted language. It isn't. It always compiles to bytecode. So even in the Groovy shell or something, it will compile the script to bytecode before it runs it. There is no Groovy. Nobody ever implemented a Groovy interpreter. But that's just some background information. What are some of the Groovy language features that we make use of also in Gradle? It's a dynamically typed language, and it supports optional static typing. So you can give the type of a variable as you would in Java, but you can also leave it off. For scripting purposes, often it's overkill to give everything a type, the return type of the method and the parameters and the local variables. And as we'll see, you can just leave it out and say def if you think it's overkill, but you can also do it the Java way. If you write some more complex Groovy, Groovy class or something, you can add the same type information as you would in Java. It has a lot of support for metaprogramming, so things like macros, both at compile time and at runtime. And Gradle uses that heavily to implement a domain-specific language, a build language, on top of Groovy. It does support a restricted form of operator overloading. So there is a fixed set of symbols, but they can be overloaded. It removes a lot of the Java syntax noise. So for example, you can leave off the type declarations, you can leave off the semicolons, you can leave off the main. You can just write statements at the top level of your file without having to put everything into a static void main inside a class. And so your programs get a lot more concise, and lots of the boilerplate is removed. Groovy has first-class support for properties. So it encodes the Java beans convention. Basically, you declare something that looks like a field in a class, and it will generate a private field and a public getter and a public setter. So in Java, you would have your IDE probably generate that. In Groovy, the compiler generates that for you. Again, it removes a lot of boilerplate code when you write POJOs, because you just have a class and you add some fields, age, name, something, and it will generate the getters and setters, and which also makes it very compatible with Java. If you then call into this Groovy class from Java, you can call the getter and the setter. You can write kind of idiomatic Java. Another great feature is that Groovy has closures. Java 8 now has something similar with Java 8 lambdas. In other languages in Ruby, it's called blocks. So that's an anonymous block of code that is code and data at the same time. So you can assign it to a variable, pass it into a method. You now can pass code around. Similar to Java 8 lambdas, but more powerful. And that's also heavily used by many of the Groovy APIs and by Gradle. Often in Gradle, when you use a closure, you don't think of it as a closure. You just think of it as the Gradle build language. But under the hood, it's a Groovy closure. And Groovy is designed to be a companion to Java, not a replacement. So if you're writing real Groovy code, not just Gradle scripts, but say you do your application in Groovy, you will use the same JDK libraries that you're used to from Java. It doesn't try to implement a whole new standard library. It just adds new classes and even new methods to existing Java APIs. So you use your regular Java util list, but suddenly you have a whole you have lots of new methods available that makes it easier to work with that list. So it really enhances what's there, rather than trying to create something entirely new. Okay, that was a very short overview of what Groovy brings to the table. There are many other good uses for Groovy outside of Gradle. For example, it's really good for writing the tests for your Java code. So even if you're a Java code base, it might pay off to write your unit and integration tests in Groovy. That can save you a lot of time. And if you're interested in that, further exploring what Groovy brings to the table, then I do recommend this book, Groovy in Action, which is the best reference for Groovy. So you'll find lots more in there than what you need to know for Gradle. But for example, if you ever get to implement your own Gradle plugins, more complicated plugins and tasks, then Groovy is a good language to do that. You can also write them in Java, but it might be easier if you need to parse XML or I don't know, what else? Parse XML, parse JSON, get something from scrape a website or something like that. Groovy is a very good language, and Groovy in Action is the reference book. And by all means, get the second edition. The hard copy, I think, is not available yet, so it's some early access preview. And actually, Groovy in Action, the book, is famous for being in that early access preview for 4 or 5 years, I think now. But it's a really good book, and get the second edition. And they'll ship the hard copy once it's out. OK, so how does this relate to Gradle? That's now more interesting. So how does Gradle make use of Groovy? How do the two fit together? As I already said, Gradle is implemented in Java, and the outer layers are often implemented in Groovy. And when you write a Gradle build script, actually, technically, under the hood, you're using Groovy. So this is an example for a Gradle build script, just to give you a first idea what it looks like. By convention, this file would be called build.gradle. That's the Gradle build script. And this is what you see here is a simple Java library build. So let's have a look. So this is valid Groovy here, but you don't think of it as Groovy, you think of it as the Gradle build language. And we'll have a chapter on the Java plugin, but just to give you a first idea, so you apply the Java plugin, which basically brings everything in that you need to build the library jar. You set some description, you say, okay, it's a version 1.0 of my library. You say external dependencies, get it from the Maven Central repository. That's the build language for declaring your repositories where Gradle will look for external dependencies. Then you say, I have a compile dependency on Spring Core version 4.05. So that's a dependencies block. That's another element of the Gradle build language. And here we configure our test task. We wouldn't have to configure it, but here we want to give it some more memory, some more heap space. So we say, whenever you start up a test JVM, give it a maximum heap size of 1 GB. And under the hood, this is really Groovy. For those of you who attended the first session, these things in curly braces, all of these are closures, similar to Java lambdas. So under the hood, you don't necessarily have to know that, but if you want to dig deeper, you are calling here a method called repositories on some object. It's actually the project object, and you pass one argument to that method, which is that code block. So that's what's happened under the hood. That's how the Gradle build language is implemented, but that's not how I think of it when I look at the Gradle build script. I just think this is the repositories block, and this is the syntax for declaring where Gradle will look for external dependencies. But if you dig deeper and start customizing Gradle and so on, if you ever need to get to that point, then it's good to understand what happens under the hood. And all of these are, at the end of the day, method calls to a regular Java object of type project. It's our Gradle API project, and you can look that up in the DSL reference, and you will find all the properties and all the methods that you can use at the top level of your build script. You find that in the DSL reference under project. So that's how you find out what language is available in here. You look it up in the DSL reference. OK, probably I already said everything that's on the next 3 slides by now. So I said build scripts are named build.gradle by default. And here are some examples of build scripts. So this, again, could be, let's say this is a build.gradle. And we have 3 statements here. That's printline is short for Java system out printline. So if you need to quickly print something to the console, you can just say print line in Groovy, and therefore also in the Gradle build script. And let's have a look at the first line. So here we say we want to print the string Gradle to the console, but we are missing the closing quote here. So this is not syntactically valid Groovy. The Groovy parser would reject that, and that's anything that's not valid Groovy syntax is also not a valid Gradle build script. So if you have a build script with just that line, then Gradle will buff and will say cannot compile build script build.gradle, something like that. So it always has to be syntactically valid Groovy. So let's have a look at the second line. That looks better. That's syntactically valid Groovy, print line zip code. Only problem is by default, a Gradle build script doesn't have a variable called zip code. So you now will get, and when you run that build, try to run that build, you will get an error and it will say something like cannot resolve variable zip code. I don't know what that is. But it's already better than the first line. And then the third line, that's the interesting one. So you have a build.gradle that only contains print line name. What do you think? Is that a valid Gradle build script? Who thinks this is a valid Gradle build script? Just this one line, print line name. Valid build.gradle? Anyone? A couple of hands? It actually is. So it's not a particularly useful Gradle build script, but it's a valid one. And what does it do? It tries to print a name. And here's the thing. If you would run that in plain Groovy, you would get the same error. Groovy would say, I can't find a variable with name, right, unless you declared it. But a Gradle build script has a name, and a Gradle project, actually. And by default, that's the name of the directory that contains the build.gradle. So it will print that out. So a Gradle project, if you look that up in the DSL reference, you will find the property name. And that's why this works in the context of Gradle, but not in a plain Groovy runtime. It's similar to in the browser. If you have some JavaScript that uses browser APIs, that JavaScript will only work in the browser, but it won't work in a plain JavaScript runtime. And there's the same relationship between Groovy and Gradle. Gradle enriches plain Groovy with an environment with an API. And so this name variable is available in a Gradle build script, but it's not available in a plain Groovy shell, let's say. Yes, and everything in the build script, such names like name and zip code, they are looked up on this project object. So look that up in the DSL reference, maybe as part of the next exercise. If you have some time left, try to find that project type in the DSL reference, and there you will find the name property. So that tells you what's available in the Gradle build script, which methods and properties are available. Okay, any questions so far? That was getting started with Groovy and Gradle. And now let's talk about the first building block. And after that, we'll have an exercise on this. And the first building block of Gradle is tasks. So what are tasks? Tasks are the basic unit of work in Gradle. So whenever you want to build your build to do something, compile the code, run the tests, deploy the documentation, all that work, the heavy lifting is always done by one or more tasks. Tasks are declared and configured by build scripts or by plugins. We'll talk about plugins later. So if you say apply plugin Java, it will bring in a number of tasks for you so that you don't have to declare them in your build script. But they're always declared and configured by build scripts or plugins. But the important thing is they're executed by Gradle. So in your build script, you never explicitly call a task and say run, compile.execute or something like that. You just tell Gradle which tasks are available, and you tell Gradle what their dependencies are. We'll talk about that in a second. And then, based on that information and based on what you enter on the command line, Gradle will figure out which tasks to run and in which order. It's important to understand that in the build script, you never explicitly call some execute method to run some task. You just tell Gradle which tasks are available, how do they depend on each other, and then you enter on the command line. That's where you tell it which task to execute. You say something like Gradle compile. And then Gradle will look in the build script for a task named compile, and if it finds it, Gradle is the one who decides which task to execute and in which order. So that's one reason why we say that Gradle is a declarative build tool. You don't write here, just a second, something like compile, test, deploy, or something like that. You just declare the tasks and their dependencies. Something like char depends on compile, and perhaps deploy depends on char, something like that. And then in the command line, you say Gradle deploy. And then Gradle will look in the build script and say, oh, there's the task that the user wants to execute. Oh, and deploy depends on char, so I have to execute that first. Oh, and char depends on compile, so I have to execute that first. So that's why we say Gradle is declarative. There was a question? Yeah, so the question is, in Maven, there is the concept of profiles. which gives you basically a way to have different variants of your build. So maybe if the current environment is Windows, then do that thing, otherwise do something else. How would you translate that to Gradle? It's true that currently there's no first-class concept of variant in Gradle. Probably there will be one in Gradle 2x. Depending on what your exact needs are, and maybe we can talk about it in a break. The easiest thing you can do is can just put an if statement in here. And that's, so if current operating system, system property or something is Windows, then declare this task, otherwise declare that task. In general, we try to avoid that. We rather try to describe everything side by side. That's another thing often. Because if you do this variant thing, so if, I don't know, if this is a release build, then do this. If it's a development build, do that. Sometimes you have the case you want to do both things. You want to, at the same build invocation, so should produce the debug binary and the release binary. And if you do that kind of conditional, then you can't do it all together in the same build. So it depends a little bit, but maybe we can expand on it on your needs in the break. Okay, this is the syntax for declaring a task in the build.gradle. So there is, we call it a keyword. So you say task, that's how you introduce a task, and you follow it up with the name of the task. So if you say task hello world, you'll get a task named hello world. And then you have the open curlies, and in here you configure the task. Everything in here, you tell Gradle further information about the task. It's all configuration. And at the end of the day, this declaration will result in a task object that implements the Gradle task interface. So if you want to know which properties and methods are available in here to configure a task, again, open the DSL reference and look for the task type. And all the methods and properties you find there, these are the things you can put in here between the curly braces after declaring a task. So perhaps I can give that a quick try, because I keep talking about the DSL reference. Let me try. So here, Gradle.org, you have the user guide and also the DSL reference. And it's versioned, so you can put in your version of Gradle that you're currently using, and you'll get the documentation for that version. And here at the left-hand side, it looks a bit similar to Java Doc, but as I said, it's higher level. Here is core types, and here is project and task, the two types I've been talking about so far. So project, that's the stuff it's all the properties and methods, so it has lots of general documentation, but here then comes a list of properties, and somewhere in here should be the name property, if you remember the print line name, and you can jump down to the detailed documentation which says this is a read-only property, so you can read it in the build script, but you cannot set it in the build script. And same thing for task. So again, let me try. Where was it here? Over here, task. There's a general introduction, the documentation, and then it has all the properties and the method. So here we have the description. So it says here there's a property description, and what that means is that inside the task, we can write description equals something. And that's how you let Gradle know, give a little document the task, so that you when say Gradle tasks will do that as part of one of the exercises, then it will print out that description. Okay. So the next concept after task is task action. So the model is every task has a list of actions. And the basic unit of work is the task, but whenever Gradle decides to execute a task, what it does is it executes all the task's actions one by one in the order they were declared, basically. And if you want to add your own task action, if you implement the task from scratch without using any Gradle task, how should I put it, any functionality, if you don't use any functionality that ships with Gradle, but write the vanilla task from scratch and will do that as part of the exercise, then you have to add at least one task action to your task. Otherwise, it won't do anything. In real-world builds, typically you will use a pre-built task type. So you would say this is a task, a compile task. And then Gradle already Gradle provides the action for you, because Gradle already knows how to compile something. But if you do a vanilla task, this is the syntax. You say task hello world, open curly, and then there are two methods, do last and do first. And this is the way how you add a task action. Do last adds it to the end of the list of task actions, and do first adds it to the beginning. In most cases, a task only has a single task action, so it doesn't matter if you use do last, do first to add a single element to the list. But another use case for do last and do first is to take an existing task and decorate it. So you have this compile task, and you want to execute this little piece of logic just before compiling or just after. And that's another use case for do last and do first. So you take an existing task, for example, introduced by the Java plugin, and then follow up with the do last and do first. And in here, you can write any Groovy code. And that Groovy code is going to be executed whenever Gradle decides to execute the Hello World task. So let me have a look in this case. When Gradle evaluates the build script, it says, OK, I have to add a task named Hello World. And under the hood, Gradle builds a regular object model, like the software you write. It's a plain Java object model that has a project object, and the project has a list of tasks, and the tasks have properties, so no magic there. And when Gradle evaluates the build script, it just builds that object model. And it passes the build script and collects all the information about the build. So here it would add the task, then OK, it has to add a task action. Do last, OK, the list of actions is empty, so it adds that task action that when executed will print the print line. But it doesn't print it just yet, it just remembers that as a task action. You're just configuring the task. So it remembers whenever I will need to be executed, I will have to execute that code block here, the print line world. And then we add another task action at the beginning. So this task action will come before the other one. And that will print hello. So what do you think will happen when the task gets executed? So it will execute both actions. This one will come first, so it will first print line hello, and then on the next line it will print world. OK. Any questions on the task actions? You cannot execute just a single task action. You always execute a task, and whenever you do that, Gradle will execute all the task actions one after another. This is what it looks like from the command line. You use the Gradle command, and then you follow up with one or more task names. So you say Gradle hello world. Gradle will pass the build script and will look for a task named hello world. And yes, I got the capitalization right. So it found the task, and this is how it prints out the currently executing task. And actually, that's not quite correct because we use the print line here. So it will actually print hello on the first line and world on the second one. A nice feature of Gradle is that you can abbreviate task names on the command line. So you're encouraged to use descriptive task names in your build script. Don't try to abbreviate them too much, like you would try to give good names to your Java classes when you write production code. Also try to give good names of the tasks you introduce, and you can abbreviate them on the command line. So for each word in that camel case task name, you have to provide at least the first character, but you can leave out the remaining characters of that word. Similar to how you may be used to that from IntelliJ or Eclipse when you look for a class name. And Gradle supports the same thing for the command line. So here we have two tasks, and we want to execute both of them in the same Gradle invocation, and this would be one way to abbreviate that. More common is if you know you only have one task which starts with sum, you can just write Gradle sum. And if it's ambiguous, if you have multiple tasks which start with sum, Gradle will tell you. Will say, OK, with sum alone, I don't know which task you want to execute. Please be more specific. That's something we often use. For example, there's a task, it's called publish to Maven repository or something. And often I know that's the only publish task I have, so I don't type Gradle publish to main repository or something like that. I just type Gradle publish, because I already know from experience that this is enough for this particular build. So it's a handy feature. OK, more important than that, let's talk about task dependencies. Who of you has got experience with Ant? OK, lots of people. So then one way to think about a Gradle task is the combination of an Ant target and an Ant task. So you can execute a Gradle task like you can execute an Ant target, but a Gradle task also has behavior like an Ant task. So you can really think of it of the combination of an Ant target and an Ant task. And like Ant targets have dependencies, Gradle tasks can also have dependencies. So here we have two tasks, and actually here we declare them. So that's again, only these two lines would be a valid Gradle build script. You would introduce two tasks which have no actions and don't do anything, but you could still type then Gradle compile Java, and it would happily report build successful. Wouldn't have done anything, but it would be a valid build script. And then we have a third task here, jar, and presumably the output of compilation and processing the resources, that's exactly what goes into the char. And so the char needs something that's produced by the compile Java and the process resources task. And that's when you need to make one task depend on others. So because the char task packages the result of compiled Java and process resources, it needs to depend on those tasks. And that's the syntax for it. So inside the configuration block for the task char, you say it depends on compiled Java and depends on process resources. So that when you then on the command line say Gradle char, it will first execute compiled Java and process resources and only then char. A difference compared to AND, you could also do that in a single line, depends on compiled Java, comma, process resources. And a difference compared to AND is that this doesn't imply any ordering between compiled Java and process resources. So even if you fuse that into a single line, depends on compiled Java dash process resources, all that's telling Gradle is that char depends on both of them, but it doesn't say anything about the order between them. You would have to add another statement, something like compiled Java should run before process resources or must run before process resources if you're concerned with the order of the two. But in general, you shouldn't be concerned whether Gradle first compiles the Java code or processes the resources. These are typically two independent things. And so you shouldn't over-specify your dependencies, because this task declaration here, this dependency declaration, will give Gradle a chance to, for example, execute the two in parallel. It won't do that today, but it will most likely do that in the future. So try to only specify semantic dependencies. So if one task produces something that the next task consumes, then that's when you need to have this depends on relationship. And this is a good example. And these are actually 3 tasks. If you say apply plugin Java, you will get, among other things, these 3 tasks with these dependencies. So the question is if you could somehow express the dependency inside a task action, inside a do last or do first, so that you can enforce this order somehow. And the answer is we'll have a whole lab actually on that. What is the difference in Gradle between configuration and execution? So this is a piece of configuration here. You are telling Gradle about the dependencies. And you cannot, if you tell it that in a do first or do last, then you would only tell it that while it's already executing. And that's too late to tell it about the dependencies. So that's also why we say it's declarative. You could try to do a task action, and then in there somehow say compile java.execute. That would be the imperative way. But that's not the right way to do it in Gradle. So you have to tell it declaratively, and then Gradle figures out when actually to call into the task implementation. So how are we doing on time? I see some clapping hands, which is a kind of a bad sign, I think. I think, is it 12:15, the first slot? We're probably already done with the first slot. Can you check it? OK, so where are we at? Next thing we're going to do is the first interesting lab custom tasks. But before that, we have a 1-hour lunch break. And I don't want to take away your lunch. So thanks a lot for listening, and see you back in 1 hour with the lab on tasks. Thanks.